Welcome to Physics Made Easy series. Today, in the first lesson, I will explain you about units and dimensions. Physics is easy or becomes easy if you are perfect in this topic, units and dimensions. Most of the students neglect this and read other chapters more and more, but this is most important. So, very briefly, it is like this. There are certain systems of measurement. So, why there are systems of measurement? Because physics is defined as a branch of science that gives the exact measurement of different physical quantities. What is a physical quantity? The one which can be measured is called a quantity. The physical quantities are again of two types. One is fundamental quantity, another derived quantity. What are fundamental quantities? Fundamental quantities are those whose units are independent. Those units are not obtained from any other units. They have independent units. So, because fundamental quantities are initially selected by our board trade of measurements, so they are in the SI system, they are length, mass, time, electric current, thermodynamic temperature, luminous intensity of light, and the amount of substance. These 7 are called fundamental quantities in the SI system, that is the system of international units and measurements. It was framed in 1960 in Paris. Previously, we have the old systems of measurement called FPS system or British system, CJ system or French system, and MK system. So they have only 3 fundamental quantities: length, mass and time. But as the science and technology advances, we required other physical quantities, fundamental quantities, that is the remaining 4: electric current, thermodynamic temperature, intensity of light and amount of substance. So this FPS system, unit of length is foot, and unit of time, mass, is pound, and unit of time is second. But in the advanced countries and the western countries like USA and UK, still you are following only the FPS system. Here we have the speed of a car in kilometer per hour. They have only mile per hour. And here we have mass in kgs, kilograms. They measure only still in pounds. So, one mile is equal to 1.609 kilometer. 1 pound is equal to 0.4536 kg or 453.6 gram, less than a half kg. Of course, second is same everywhere. So, this is foot-pound second system, old system, now old for us. And in practice, that's still going on in the western countries. Centimeter, gram, second system, and meter, kilogram, second system. But now let us come to this SI system. In the SI system, the definitions are given more accurately. Previously, 1 meter is defined as distance between 2 points marked on a platinum iridium bar kept in the board trade of measurements, Paris. Simply like that. But whereas in the SI system, this is not so accurate definition, because accuracy is very less. So because now we are going to other planets and stars, astronomical distances are very large. A small error in a unit gives a big error in the long measurement. So that's why meter is given a very accurate definition in SI system. So 1 meter is defined as 1 by 299, 762, 458 of the distance travelled by light in vacuum in 1 second. That means it is nearly 1 by 3 into 10 to the power of 8 meter in 1 by of the distance travelled by light in vacuum. 1 by 3 into 10 power 8. So this is actually 2.99 into 10 power 8. The round figure is 3 into 10 power 8 of the distance travelled by light in vacuum in 1 second. That is the accurate definition given to meter in the SI system. So similarly other definitions are given very accurately. So therefore also they gave one more definition for meter in the SI system, 1650 763.3 times the wavelength of orange light in vacuum in terms of wavelength, because wavelengths are expressed in angstrom units. 1 angstrom is a very small unit, as small as 1 angstrom is equal to 10 power minus 10 meter. 1 angstrom is equal to 10 power minus 10 meter. The wavelength of light is expressed in angstroms. So 1 meter is defined as 1650 763.3 times the wavelength of orange light in vacuum. So like that the definitions in SI system are very accurate. Thus similarly the other fundamental units are also given very accurate definitions. So here certain things, while studying in units itself, you will get certain models. See, 1 Kelvin is, what is 1 Kelvin? Kelvin is the unit of thermodynamic temperature or absolute temperature. 1 Kelvin is 1 by 273.3 of triple point of water. See, while studying in units itself, you will get certain models, you will get some definitions, some concepts which will be asked in your competitive examinations like NEET, IIT, CBSE exams, etc. What is a triple point? I said just simply triple point. And that is a particular temperature. And in that temperature, this part, this much part, 1 by 273.3 of the temperature of that temperature, what is called triple point of water, is equal to 1 Kelvin temperature. What is triple point? You will now know, because it's an important point in heat. Triple point, triple means 3. Point means it's a particular temperature. It is the temperature at which a substance exists in all the 3 states at a time. All the 3 states means solid, liquid, gas. All the 3 states at a time it will coexist. How it is possible? Suppose you have water, liquid state. Now suppose water is boiling at 100 degrees C, then you will see liquid and gas. And suppose you have ice, so solid. Suppose the foams are coming from ice, solid and gas. But how solid, liquid and gas, all the 3 exist at a time? They all exist at a particular temperature at the normal pressure. That particular temperature is 273.3 Kelvin. So therefore, at 273 Kelvin temperature, water exists in solid state, liquid state, and also in gaseous state at a time. Such a temperature is called triple point. So triple means 3. So now you see what you are now learning simply systems of measurement. But what the definition you got now? You got the definition of triple point. What is triple point? The temperature at which a substance exists in all the 3 states at a particular temperature and at a particular pressure also. So like that, you got some heat point also here. So these are called concepts. So therefore, to get physics, you should have concepts first, models. If you know all the models, in this chapter also, we have some models. See, anybody sets a question paper on a particular model, a question on a particular model. if you also study all the models beforehand, you can answer any question very easily. That is why I say this is physics made easy series. So like this, you have SI system. Now fundamental quantities are those which are having independent units. Now what are derived quantities? The quantities other than fundamental quantities are called derived quantities. That means whose units are dependent upon the units of fundamental quantities or fundamental units. I can say the units of fundamental quantities as fundamental units, units of derived quantities are derived units. For example, area. Area is a derived quantity. For all these things you should know their definition. Definition of a quantity. That means you got the concept, you got the physics. You will get physics right from here itself. Here only you will get physics. If any student is perfect in units and dimensions, definitely he will be perfect in all other chapters. So what is area? If you want unit of area, you should know the definition of area. Area is given by the product of length and breadth. So unit of length, so for example a square, you have the area of the square is equal to length into, the area of the rectangle is equal to length into breadth. Area of square, L into L, L square, L is equal to side. So L means meter, B means unit, breadth is also a length, length is a length, breadth is a length, height is also a length. So meter into meter. So if you want the unit of area, you should know its formula, that is for a rectangle L into B, M into M. Length is this. So if I say this is length, this is height, this is also measured in meters and this is also measured in meters. LBH all are lengths only. So meter into meter, meter square. Meter square means that is you can call it as a square meter. Like that unit of area you got. You can ask any quantity, you can find the unit of that physical quantity. For example, say volume. Volume of a cube, rectangular cube, L into B into H. So H is also having the unit meter. Now what happens here? Meter square, instead of meter square it becomes meter into meter and meter cube. Or I can say cubic meter. This is the unit of volume. Like that unit of volume. If for anything, suppose you want the unit of velocity. See, that's why what I say this is most important topic, because you will get everything in this first topic. That is, you go to kinematics, they will get displacement. Displacement as bar. Displacement is a length, shortest distance between 2 points. You should know that point. So shortest, this unit is meter. And what is the unit of time? You know it is second. What is velocity? Velocity is equal to displacement by time. The rate of displacement is called velocity. The rate of displacement, if I write bar on it, it is a vector quantity. What is a vector quantity? A quantity having both magnitude and direction. So it has both magnitude and direction. Suppose there are 2 points A and B. Now if you travel along a straight line, this is having a direction. It is a straight line, is having a direction. Suppose you go from A to B along a curve, then there is no specific direction here. You started in this direction, you changed your direction, like this. The direction is continuously changing, not a particular direction. Here there is a particular direction. If I start here to catch you with a high speed than you, then I can catch you. If I start here in this direction, because you started initially like this, you will change your direction like that, but I will go like this. I can't catch you. So therefore there is a particular direction in the shortest path or straight line. So that quantity is called vector quantity, having both magnitude. The length of the path is the magnitude. Here the length of the path is also a magnitude, but direction is not specified. So therefore, here this is a vector quantity. I will call it as displacement, as bar, and I will call this as a distance, only S. This path, the length of the path is called distance. This is only path. This is displacement. The length of the path is called distance. Of course, unit is same for both of them. Distance is measured in meter, displacement is also measured in meter. But this is a vector quantity, this is a scalar quantity. You know, I wanted the unit for velocity. So velocity, I should know the definition of velocity first. That's why I say, to make physics easy, you should know the definitions first. If you want the unit of velocity here, though it is the first topic, it covers the entire physics. That is both plus 1 and also plus 2 or junior enter or senior enter or 8 or anything. This covers all chapters in physics. Because velocity is not in this here, but I want the unit. But velocity has a unit. So what is that unit? For that you have to go to kinematics. Where what is said in kinematics? Velocity is nothing but rate of displacement. Displacement means that is s bar by t. So s is L length, t is also time t. So I can write this L by t means meter per second. Unit of velocity is meter per second, or I can say meter second inverse. Actually here it is s means s power 1. When it goes to numerator, the power becomes negative. Meter second inverse. So like that, velocity has the unit meter per second or meter second inverse. Suppose even speed also have the same unit. The speed means the distance travelled per second, only s by t, not s bar by t. That also has the same units, L by t. But speed is a scalar quantity, velocity is a vector quantity. Suppose you want the unit for acceleration. Actually, this is the chapter units. So you should be able to find out the unit of any quantity. So acceleration. Acceleration means rate of change of velocity. Change in velocity per second. Delta v by delta t. Delta indicates a small change. So velocity, what is velocity? It has a unit called meter second inverse. And similarly, time is second. So this s power 1 also goes to numerator and becomes another minus 1, minus 1, minus 1, minus 2. Meter second inverse 2. Or I can say meter per second square is the unit of acceleration. So to get the units, you should know the definitions, or the concepts. That is how physics becomes easy or made easy, provided you know the definitions of the different physical quantities or the concepts. So now you can get even force very easily. See force, how to find the unit of a force. So unit of force here. You know the formula in Newton's laws, which you have studied in your lower classes like 9th class or even plus 1. You have the formula F is equal to ma. You have the formula F is equal to ma. So in this, m means kg, mass, unit of mass kg. Acceleration means meter per second square. Kg, meter per second square, is the SI unit or MKS unit of force. In SI unit, each unit is given the name of a scientist. That scientist, that is here it is Newton. So unit of force is Newton, N, capital N. Capital N is the unit of force. If you want to write Newton in total words, you have to write as N-E-W-T-O-N, small letter. If you want Newton, you have to use small letter. If you want symbol, you have to use capital N. So force is equal to MA. That's unit of force you got. Similarly, you can get the unit of any other physical quantity. Any other physical quantity, say like work. This you got in your 8th class itself. Work, you know the definition of work. Work is given, work is said to be done and the position of a body is changed. But the work is measured by the product of force and distance moved. Work is measured with the product of force and the distance moved. So if I push a body with a force F and the body moves a distance S in the direction of force, that is important. Then the work is given by, work done is given by F into S. So Newton second, Newton meter. This is not time, it's distance. Newton meter. Newton meter is given another name, another scientist, joule. So it is called joule. The unit of work is joule. Similarly, you have power. Power is equal to work done per second. Work by time. Work by time means joule per second. It is given another name of scientist, watt. W-A-T-T. Like that, you can get the unit of any physical quantity provided you know the definition of that physical quantity. So every student must remember at least the units of velocity, acceleration, force, work, power and energy. Energy and work have same units. Like this, the units can be obtained very easily for any physical quantity if you know the definitions or a formula. For example, you want the unit for gravitational constant. You have gravitation chapter in your 9th class itself, in your first year intermediate or +1. So in gravitation, we have a formula. Any two bodies in the universe will attract each other with some force. That force of attraction is given by F is equal to G into m1 m2 by d square. Suppose there are two bodies of masses m1 and m2 separated by distance d. Now they attract each other with a force. That is the gravitational force of attraction, which is given by that F proportional to m1 m2, product of the masses, and inversely proportional to the square of the distance between them. This is called Newton's law of gravitation. And if you write like this, F proportional to m1 m2, product of masses, and inversely proportional to the square of the distance between them, combining these two, you get F proportional to m1 m2 by d square. And if you replace this proportionality with equality sign, you will get a constant anywhere. That constant is called constant of proportionality. Here this constant of proportionality is given a specific name called Newton's universal gravitational constant. F is equal to G, capital G, symbol is capital G. Because G's are two, one is small g. The small g is acceleration due to gravity. This capital G is universal gravitational constant. So this kind of clarity should be there for any student to get physics easily. So F is equal to G into m1 m2 by d square. Now this capital G, on this capital G, many times the questions are asked in public examinations, in competitive examinations. What is the unit of capital G? What is the dimensional formula of capital G? What do you mean by dimensions? Dimensional formula means a formula relating a physical quantity with the fundamental quantities. So I will show you now. So formula relating this physical quantity or this physical quantity with the fundamental quantities L, M, T and etc. So F is equal to G into m1 m2 by d square is called the gravitational force of attraction between any two bodies of masses m1 and m2 separated by a distance d. Now here the constant of proportionality capital G. Capital G is called Newton's universal gravitational constant. And how to find the unit for that? So for that it is very simple. For the unit of force is Newton. Capital G Here it is kg, mass, another mass, another kg, distance square, meter square. D means distance, d square means meter square. Now capital G has the unit Newton meter square, cross multiplication. Newton meter square, kg square, kg into kg square, that comes to denominator. The unit of capital G is Newton meter square per kg square. F is equal to G into m to d square is known to every student, but even from a lower class. But when I ask you to find the unit of capital G, you get confused. Why? You are not able to apply what you know. You know the things, but you are unable to apply that. If you simply apply it like this, you will get the unit of any physical quantity. F is equal to G into m to d square. F means Newton, that you know. Mass means kg, you know. Mass means kg, you know. D means distance, you know. D square means m square. Now only leftover point is capital G. Now capital G is equal to Newton meter square per kg square. This goes to numerator on cross multiplication. This comes to denominator on cross multiplication. So capital G has the unit called Newton meter square per kg square. This is how, if you know the formula or if you know the definition, you can find the unit of any physical quantity. Usually you will know the formulas because you will read them in your regular text book. So you know the universal gravitation constant, universal law of gravitation. But to find capital G, what is difficulty for you? You can simply do like this. So similarly, small g. Small g is a very easy thing. That is, here you will get the entire physics if you know the units and dimensions. So F is equal to mg. Here F is equal to mg. Earth attracts each and every body towards its center. For falling body, the velocity will go on increase. When the velocity is increasing, it gets acceleration. Acceleration means you will not represent it with A, but with G. So because acceleration due to gravity. This acceleration of a falling body is due to gravitation of the earth. So therefore I will call it as acceleration, of course, but due to gravity. Because it is due to gravity of the earth, the velocity is increasing. I will call it as acceleration due to gravity. But I know F is equal to ma, a fundamental formula. In the place of A, I will write G, because this is acceleration due to gravity. This A is equal to G. Now, here again simply, F mean, you can find out value of a unit of G again here. So that is Newton, kg, G. Or simply, G you can write Newton per kg. But what about that? Acceleration I already discussed about this, Newton per meter square. Both are same. Newton per kg or meter per second square, both are same. How they are same? I told you Newton, how you got Newton? MA, kg meter per second square. F is equal to MA by kg. Kg gets cancelled. What is left over? Meter per second square. So the unit of acceleration due to gravity, I can call it as meter per second square, or I can call it as Newton per kg. Here the students will be put into confusion. Suppose I will give you a multiple choice question. The unit of acceleration due to gravity. 1 meter per second, wrong. 2 meter per second cube, wrong. 3 meter per second, meter square per second square, wrong. 4 Newton per kg. You always look for this kind of a unit, but he changed it like this, Newton per kg. F is equal to mg, g is equal to F by m, F is Newton, F is kg is mass, F by m, g is equal to F by m, Newton per kg. So it should not be confusion. If you already study about this like this beforehand, before you go to the exam, you will not get confusion. Of course, there and then also you can think, provided you are so smart. Or otherwise, if you already read about this or know about this through a teacher, then you can easily identify the answer. If I don't give this unit, this becomes the unit. Or if I give both, say first option Newton per kg, the unit of acceleration due to gravity, first option Newton per kg, second option meter per second square, third option both, fourth option none. Third option becomes the answer, both Newton per kg and meter per second square. So both are same. So like this, units is so important. With the help of, if you are perfect means in units, you are perfect in entire total physics is in your hands. That's why I say physics made easy if you know well about the units. Not only this way, another way of finding units is there. Another way of finding the units is knowing the dimensions. Dimensions means, I told you, it is the relation between a physical quantity and the fundamental quantities. What are fundamental quantities? These are all fundamental quantities. Except fundamental quantities, all other are called derived quantities. For example, the first derived quantity I will call as area. Area is equal to, for a rectangle, L into B, or a square, L into L. So L into B. I said already L means length. Also breadth is also a length, height is also a length. So area is equal to length square. What about mass and time? They are not there in area. So therefore this I can write m power 0, L power 2, T power 0, because there are no dimensions. Anything power 0 is 1. Remember, anything power 0 is 1. So 1 into L square into 1 is only L square. So you can write the dimensional formula of area as m power 0, L power 2, T power 0, or simply L square. It doesn't matter. Now what is the unit of area now? L square. L square means meter square. Dimensions are useful to know the units of physical quantities. So you got the unit here like this. If you know the dimensional formula, right from its definition again. So you get the unit of that area. Similarly, you want the unit of dimensions of volume. Volume is, for a rectangular cube, LBH means L into L is equal to L cube. If you want to write remaining also, m power 0, L cube, T power 0. So here the unit is L cube. L cube means meter cube. Meter cube or cubic meter. Cubic meter is the unit of volume. Sometimes mostly you will see cc, cubic centimeter. Cubic centimeters means 1 ml, 1 milliliter. 100 ml or 1000 ml. 1000 ml is 1 liter. On the water bottles, if it is written as 1 liter or 1000 ml. So 1000 ml means 1000 cc. Cubic centimeter is equal to 1 milliliter. Cubic meter, meter cube. Like that, unit of volume you can get. See, you can see the wonders here like this. Suppose, what is the dimensional formula of velocity? I said velocity is displacement by time. Velocity is displacement by time. Displacement is nothing but length. L by T. L by T means, what you write? L power 1. T means T power 1. When it goes to numerator, becomes T power minus 1. If it is T square, becomes T power minus 2. It's T power 1 only, T power minus 1. So what is the unit of velocity here? L means meter. T power minus 1 means second power minus 1. Second inverse 1. You got meter second inverse 1. Or you can simply say meter per second or meter per second. We can get the unit of velocity by knowing its dimensions. How many dimensions are there for velocity? One dimension in length minus one dimension in time. No dimension in mass. What about the dimensions of volume? Zero dimension in mass. These powers are called dimensions. The powers of the fundamental quantities in the dimensional formula of any physical quantity are called dimensions. Volume has three dimensions in length, zero dimensions in time, zero dimensions in time. Only it has dimensions in length, no other fundamental quantity. Suppose you want acceleration, any student should know at least this: displacement, velocity, displacement is L, acceleration, force, work. So acceleration, change in velocity by time. So you can write it as V minus U by T or delta V by T, change in velocity by time. Velocity means L power 1, already you know, T power minus 1. By time means T. So what is it? L power 1, T power minus 2. This plus 1 also comes to numerator. L power 1, T power minus 2. So what happens to its units? Meter second inverse 2 or meter per second square. Meter per second square for acceleration. This is what we got previously in the definitions. Now you got from dimensions. So units can be obtained from the definitions, from the dimensions, but for anything you need a concept. These are called the concepts. So if you know a concept about a physical quantity, you can play with that. You can do anything with that. So like that, dimensions are there. So suppose force is there. You want the unit of force or the dimensions of force. You can simply say force is equal to F is equal to ma, mass into acceleration. You have this is a standard formula. Mass means m power 1. Acceleration means you got now itself L power 1 T power minus 2. L power 1 T power minus 2. Now this is kg meter second inverse 2. This kg meter second inverse 2 can be written as Newton. Like that. So you can play with the physics if you just know certain things. Velocity, displacement by time, acceleration, change in velocity by time, force ma, work F into S. Work. I'll show you the magic of physics now. I will show you the magic of physics now. Of course, work F into S, force into displacement. That is m power 1, L power 1, T power minus 2 into L. So it is m power 1, L power 2, T power minus 2 is the dimensional formula. Unit kg meter square second inverse 2 or joule. Suppose you want power, work by time. That means total by T. M power 1, L power 2, T power minus 2 by T. It becomes T power minus 3. M power 1, L power 2, T power minus 3. Unit I can say joule per second or watt. WATT, not WHAT. WATT. What is the name of a scientist? So like this, you can get the dimensions. From that you can get units. Just from definitions you can get the units. Now I will just make a wonder here. That is, suppose you want dimensions of a physical quantity which is not even studied by you, but you know the definition. For example, what you want? What is that physical quantity you want? For example, you want the dimensional formula for surface tension, which you have not even heard. You want the definition for the dimensional formula or the unit for surface tension. What is surface tension? The surface of any liquid acts like a stretched elastic rubber membrane. The surface of any liquid behaves like a stretched elastic rubber membrane. That is why the mosquitoes or the small insects can walk on that, because it's acting like a floor for them, not for human beings. The surface tension definition, if you know, that is denoted by capital T, you can find its unit. What is its definition? Afterwards, when you get this chapter, definitely you will read this definition as force acting, force per unit length. You will study it as force per unit length. If you just know that point, you can get the unit of it or dimensions of it. It's the force acting per unit length. Surface tension is defined as force acting per unit length on the surface of the liquid. Force per unit length means, what is force? M power 1. This you must know. You should not forget the units or the dimensions of velocity, acceleration, force, work, power. These you must remember. What is the dimensional formula of velocity? L power 1 t power minus 1. What about acceleration? L power 1 t power minus 2. What about force? M power 1 L power 1 t power minus 2. What about power work? M power 1. You must just, even you are sleeping, you must be able to say this. What about power? M power 1 L power 2 t power minus 3. It is not difficult, you can do it even at that instantly. Because velocity is distance by time, displacement by time. S by t, L by t means L power 1 t power minus 2. Acceleration velocity by time, so this by time t power minus 2. MA, M into this, work, force into distance into L square. Power by time, work by time, t power minus 2, t power minus 3. Like that, it is not even difficult to prepare at the moment, but better you remember. Certain remembrance is also necessary to make physics easy. Certain things, very small things. Very big things can be made easy by that. If I want surface tension, dimensional formula, it is F by L, force per unit length, by L. L and L gets cancelled. What is then? M power 1 t power minus 2. Tension means force. Tension means force. So therefore, if somebody is forcing us, what we say? Don't put me in tension. Tension means force. A string is there. If you pull it with a force, it gets a tension. So therefore, like that, that's why here I will ask you a question in NEET exam or IIT exam. What question I will ask you? A physical quantity that represents a force but not having length in it. That force is having length. Surface tension not having length in it. No L here. In the force there is L. It's also a force, but no length in it. In this way we will ask the questions in final exams. They are called models. Once you know a model, all the models in a particular chapter, you can answer any question in that chapter. That's why we teach models in each chapter. So that is how dimension, many things can be done like this. For the first year quantities or for the second year quantities, any things you can do or any magic can be done if you know the units and dimensions. For that, all you need is their definitions. So therefore, here the other things today, that's how I completed the finding of units here. Now just two more points I will tell you. By that I will stop this episode. Now here n proportional to 1 by u. That's just a model. N proportional to 1 by u. Or nu is a constant. What does it mean? This is u means unit, n means numerical value of the physical quantity. If the unit is big, numerical value becomes small. For example, I have a particular length here. This length is say 1 meter. Now this is the meter is the unit here. If I select centimeter as unit, this becomes 100 centimeters. only 1 meter, only 1 here, because unit is big. The unit is small, numerical value is big, 100 centimeter. And if I make the unit still smaller, it becomes 1000 millimeter. 1 centimeter is equal to 10 millimeter. So therefore this becomes, if the unit is made still smaller, the numerical value becomes still larger. The same thing I will write as only 100 centimeters. The same thing I will write as only 1 meter. The unit becomes big, numerical value becomes small. Or the unit becomes small, numerical value becomes big. For example, you have got 1 kg of rice. If you express that kg in grams, 1000 grams. Unit is small, numerical value is large. Like this is one model. Any is constant. And finally, for today's lesson, principle of homogeneity. This is one model. From this model, you will be asked questions. What is this principle of homogeneity? Homogeneity means same kind. Homogeneity, heterogeneous means different kinds. Homogeneity principle. What is the principle of homogeneity? Suppose I have an equation here. X is equal to A0 plus A1t plus A2t square. It's the kind of questions you will get. X is equal to A0 plus A1t plus A2t square. If X is any quantity like length, if I say X is length, A0 should be length, A1t should be length, A2t square also must be length. So only same kind of quantities can be added to each other or subtracted from each other. Different kind of quantities cannot be added to each other or subtracted from each other. Addition and multiplication can be done between any quantities. See, all these three should be lengths only if this is length. If this is velocity, all these things must be velocities only. Only same kind of. For example, you see 1 kg plus 2 kg. How much it is? 3 kg. So both are kgs, they are added. Suppose I have 1 kg plus 1 meter. Can you add this? Kg plus meter. So you cannot add this. This is wrong. So different quantities, same quantities. Mass can be added to mass. Mass cannot be added to length. Mass multiplication can be done between any two quantities. Or division can be done. But addition and subtraction is done only among same kind of quantities. That is called principle of homogeneity. Now I want the unit of A0. Or what is A0? If I say X has length, A0 is also length. What about A1? What about A1? A1t is equal to length. A1t is length. What is A1? L by T. What is L by T? Velocity. Length by time is velocity. Rate of displacement. L by T, L power 1, T power minus 1. Yes, therefore here A1 becomes a velocity. A1 represents a physical quantity called velocity. What about A2? A2 T square is also length here. All should be lengths. But what is A2? L by T square. T2 square comes to denominator. So L by T square. L by T square, what is L by T square? Acceleration. Meter per second square. Unit of acceleration. That's why I said physics becomes easy provided you know the unit of velocity, acceleration, force, work, power, energy. So meter per second square, Newton or kg meter per second square, work, joule, power, work by time, watt, energy is also having same units as work. Like that is the principle of homogeneity. In your next class, on the principle of homogeneity, you will get a question like this. You know gas equation, PV is equal to RT. I think you got it in your lower classes itself. But actual form of it is P plus, with this I will stop, P plus A by V square into P minus B is equal to constant. It is not simply PV is equal to constant or PV is equal to RT is not correct. Or we can say P is equal to RT. This is not absolutely right. That is certain, with certain assumptions it is written. Because the intramolecular attraction between the molecules is neglected in this case. The volume of gas molecules in the container is neglected in this case. But in this Van der Waals gas equation, they are also considered. So therefore, if this is not P pressure, P plus A by V square, V volume. V is the volume of the gas molecules. What is the volume of a gas? The volume of the container itself is the volume of the gas. Volume of the container is the volume of the gas. Volume of the container means in the volume of the container you have to subtract the volume of the gas molecules. So that is V. So therefore, like that, pressure means force exerted by gas molecules on the walls of the container. But if a molecule is going like towards this or attracted by the wall, another molecule attracts it backwards. So therefore then the intramolecular force is also to be considered. Then it becomes P plus A by V square, Van der Waals gas equation. Now I want the dimension formula of A and B. Now you will make use of the principle of homogeneity. If V is volume, B must also be volume. V is volume, B is also volume. Therefore, B is equal to V L cube. That is meter cube. Dimensional formula of B is meter cube. What about A? If P is pressure, A by V square is pressure. Pressure has a dimensional formula. Pressure is equal to force by area, not power, it is pressure. Force acting per unit area is called pressure. You got in your lower classes like 8th class. Force means m power 1, L power 1, T power minus 2. That's why you must remember it immediately. A means L square. What about this? M power 1, if plus 2 comes to denominator becomes minus 2. 1 minus 2 minus 1. T power minus 2. This is the dimensional formula of pressure. So therefore A by V square must have the same dimensional formula. So A by V square. V means L cube. V square means L cube into L cube. L power 6. So P is equal to A by V square. If L square comes to this side, becomes L power minus 1 into L power 6. So A is equal to M power 1, L power 5, T power minus 2. Of course, today I gave a big lesson, but if you know like this, all these physical quantities and the dimensions, the concepts, physics becomes very easy. If you share it to others, it will be more useful to all of them.